நான் சேர்ந்துக்கிறேன்.
நான் உனக்கு இப்ப அனுப்பி
Good evening, participants. Great evening to you all.
Good evening, ma'am.
Yes.
Good evening, ma'am.
Yeah, very good evening. So a kind request is that the attendance will be considered those who have logged in through Microsoft Teams. So kindly make yourself available here instead of giving your attendance in the WhatsApp group. So that is just for a reference, but mainly we will be considering the attendance based on the record which is given by the teams to us.
Madam, for your information, the resource person joined the meeting.
Okay. Ma'am, you make her as a presentee.
Made us, ma'am.
Okay. Yes, fine. Ma'am, very good evening, ma'am.
Yeah,
Adilakshmi,
hi,
ma'am.
hi everyone.
Yes.
Good
One
evening,
second,
good
Yes.
evening, ma'am.
Agila, ma'am. 1 second. We will
Ma'am,
check her whether she can have her screen to be presented.
yeah,
Let me
ma'am,
check
you
with
also
the
please
assistant.
turn on your camera, ma'am.
Yes, ma'am, I did,
Okay.
I did.
Okay, ma'am. Yeah, now we can see. Yes, ma'am, you try sharing your screen also, ma'am. Meanwhile, I'll introduce
Yes,
you, then we'll start the
sure,
session.
sure, sure, sure.
Yes, welcome participants again. Welcome you all for the day two of our 6-day online FDP on demystifying transformers, the brains behind generative AI. It's my privilege and honor to welcome and introduce our speaker, Mrs. Adilakshmi ma'am. She is currently working as a senior data scientist and solution architect, bringing over 11 years of industry experience and 6 years of academic involvement. Over the past 6 years, ma'am has specialized in data science and machine learning domains, contributing her expertise to leading organizations such as TCS, Capgemini, Cropin Technology Solutions, and Green Olive Innovation Labs. She has consistently demonstrated strong capabilities in gathering business requirements and conducting in-depth data analysis. Our technical proficiency includes deploying a scalable machine learning models using Docker containers and improving operational efficiency through Python and AWS-based workflows. As a collaborative and results-driven team leader, she brings significant value to organizational goals. During her doctoral research, she applied natural language processing techniques for topic modeling and analysis of online hate content, along with evaluating the user trustworthiness and source reliability using advanced fact finding algorithms. We are happy to see you and being with us, ma'am. Thank you so much for accepting our invitation for delivering a talk titled Generative Agents in Multi Agent Design Pattern, a case study on software engineering and testing. Over to you, ma'am. Thank you.
Yeah, thank you, Akhilandeshwari ma'am. Thank you, Anita ma'am. Good evening to everyone present here. Ma'am, do you want, is this getting recorded or?
Yes, ma'am. Yes, ma'am.
Yeah,
It's
okay.
automatically getting recorded.
Okay. So good evening to everyone. So we will look at the course outline and the topics that are going to be covered as part of this. Initially, we'll look at the big picture of the generative AI universe. We will look at the introduction to AI agents. What are the different types of AI agents? Um, so hierarchically, how do they, from the years, how they have been evolved over a period of time? What are the design and architectural patterns of AI agents? Some of the real world use cases, one case study example, and we have a quiz time and question and answers towards the last 10 minutes of the session. At any point of time, if you have any questions, we can have it in the chat or I will get them answered towards the end of the session because I'm not able to see if there are any questions. So let us get started. So if you look, there is this Gen AI universe that has been there for the last 3 years that have come out. So the LLMs are like the sun in this entire Gen AI universe. So the planets, which are the prompt engineering, fine tuning, the RAG, AI agents, they are revolving around the LLMs like planets. So in this particular topic, why I wanted to bring in this Gen AI universe is that all of these will be covered as part of this entire FDP workshop. And I am concentrating on the AI agents part, which is nothing but the fourth planet in here. You all must have known and heard these jargons, right? LLM is a large language model. which is like the sun in the entire solar system. So all of these techniques that we are talking about, or the jargon that we are hearing, they are running, I mean, they are moving around the LLMs only. That means it's all always an API call, a request and a response call to the LLM. So prompt engineering is a way in which the users connect with the LLMs with the help of a API call, and we give our system prompt in the form of a template. So there are different kinds of prompt engineering is like an ocean of information out there with the different ways that you can interact with the LLMs and get your responses, like zero shot prompting, one shot, multi-shot, and so on. Fine tuning is a way of fine tuning the LLMs. Not all LLMs are fine tunable. There are certain parameters, and depending on the application that you're trying to deliver to the deliver and deploy, fine tuning may or may not be required, and certain parameters of the LLMs can be fine tuned. You will be looking at it in some parts of the later part of the this entire workshop. RAG, as you know, it's a retrieval augmented generation. This will come into picture whenever, though the LLM is having the capability to actually answer the response, but it happens that whenever it does not have customized information about the particular application that we are going to build. So whenever we have certain documents or information on which we need to have the LLM answer the queries, then RAG will come into picture. So it's a kind of an, you can imagine like a database or a data store where your documents can be stored, and then using the embeddings, the search and the retrieval mechanisms become easier, and you will have the exact information when you query the LLM with your prompt, and you get the response back. So now when you look at the AI agents, that is where I am trying to concentrate how Gen AI has contributed. The AI agents actually existed from even in the 1950s as well. We can see how they have evolved over a period of time and how Gen AI, the LLMs, have contributed towards enhancing its capabilities. So with that, I proceed to the next slide. So this is also one of the key things that I wanted to bring to your notice, that whenever we are making any LLMs and we are using them for some of our industry frameworks. Okay, there are a number of parameters on which we need to concentrate on when we want to deploy. As a data scientist, as a data engineer, as a business team, as an infrastructure team, as an analyst, your engineer, as an engineer, and as a legal team. So you know that there are so many LLMs out there, like so many LLMs from OpenAI itself, like GPT-4o, GPT-4 Mini, Turbo, and then you have also Claude, Gemini from Google, and many more. So, or even when you take one single LLM with a different set of fine-tuning parameters, when you want to make a call on which LLM to be deployed, you will have to look at all of these parameters that are there. Some of them to bring to your notice are capability. So is the LLM capable of being used for fine tuning, or is the LLM capable of getting that required output? Is the LLM fitting into our use case? So these are certain questions that we need to ask in order to decide on that particular LLM. So the second parameter that comes into picture is the accuracy of the LLM. So is the LLM's accuracy good enough for us to deploy it in this particular application that we are going to build? So the other important factor that comes into account is the cost, because the cost around an LLM, it's about the tokens, how much it is using as the input tokens, and in the response, how many tokens we are getting it back. So many of the solutions that now we are trying to use LLMs are consuming a lot of cost without our knowledge, because everything is an LLM call at the end. So we need to be very legitimate when we are using the cost, see that we don't have high cost involved. The other parameter is the technology, whether you are using it using Java, Python, or some other programming language. So the next parameter is how are you able to maintain your LLM? It's easy to get your task done, but when we want to deploy and maintain it further in your production machines, so that brings in an monthly revenue that keeps running, because when you deploy your LLM and you have the input tokens used on a daily basis, so you will end up having a monthly cost of around 200 euros or 300 euros, depending on the application. So you will have to keep into account the maintainability of your LLM as well. So the next parameter is the support that is required for the LLM. So is it required that some number of FTEs should be involved after the deployment in production, that they will be supporting in terms of any errors that happens in production, in terms of when the application is down, do you want to bring it up and so on. The other parameter is the latency. How much time does your system take to respond back to the user? So that is also very important parameter. The other parameters are scale. So can the LLMs be used for how many number of users? Is it 100, 200, 300? If it goes high at some point of time to 1000, is it able to handle? All these questions have to be answered. So in terms of infrastructure, where do you want to deploy your LLM? Is it locally or in what cloud? Is it AWS, Azure, GCP, IBM, or your own local machine? Is it public, private, hybrid, and so on? So in terms of security also, this is a very good. The last three are very, very crucial for the deployment of LLMs in the current industry standard. All the industries are struggling to get their compliance, security, and privacy checks done even before their deployment. So there are a number of R&C approvals that happens. In terms of security, we need to check whether the data that we are using as part of the LLM and even the not only the data, but in terms of the model that you're using, the explainability, the ethics, are we in aligned with the client, and are the privacy and compliance taken care? So all these requirements also have to be checked with a separate team called a risk and compliance team and a legal team. So that so all of the stakeholders that are involved in making these decisions are the data scientists, the data engineers, the business analyst, the legal team, and the analysts. So I'll go to the next slide. So with this, I'm actually trying to bring to you the importance and the different parameters that are taking into account while you're making your LLM decision making in the framework. So now we go into AI agents. So what are AI agents? So we all know that AI agents are software entities that operate autonomously to perceive the environment, make decisions, and to act to achieve specific goals. So the main importance of AI agents is that they have these four properties. Autonomy. Autonomy is nothing but the power to think and act on their own, like how humans do. Reactivity. So responding to the changes in the environment is reactivity. For example, a chatbot based on the user input, when different users are trying to interact with the chatbot, depending on what the user has given, it will accordingly give the answers. Proactivity. Proactivity is nothing but anticipating needs and acting to achieve goals. For example, AI assistants scheduling tasks proactively, depending on how our previous behavior, right? Social ability, the ability to interact with other agents and being able to schedule the tasks proactively. So all these four key features are for the AI agents, which is not there in terms of the traditional software. So the main difference between the traditional software versus the AI agents is that in the traditional software, we have an input, a process, we validate certain steps and we get the output. But in terms of an AI agent system, it's kind of, so what happens is that AI agent system is similar to us like humans. It is able to make decisions, take actions. It's also dynamically able to sense the environment, and it will process and analyze the data, still get into the loop of make decisions. And as part of that, it can build a model, process, analyze, make decisions, and so on. So this is a loop that keeps going on and on and on until it gets the desired results to the user. So if you look at the differences, major differences in terms of the key features, the autonomy, adaptability, interactivity, and the goal-driven behavior. If you look at for the AI agents, we have a self-directed decision making compared to the pre-programmed responses. We have a dynamic adaptation to changes, which is actually static in terms of traditional software. We have a continuous environment interaction in terms of AI agents, whereas for traditional software, it is always user-triggered actions. So it achieves high-level objectives, whereas in a traditional software, it executes predefined tasks. So the AI agents and this agency has been there, as I told you earlier, from 1950s with the Alan Turing's foundational test in machine learning and machine intelligence. Over a period of time, we from the Alan Turing machines, we turn into rule-based systems Then we have reactive agents and behavioral-based robotics. Then we turn into theoretical framework, and then we came into complex decision making using dominant in AI. And now in 2020s, we have come into agentic AI, where we have integration of self-improvement capabilities and collaborative capabilities. So the native architecture of AI is agentic-centric workflows, iterative self-improvement, seamless tool and resource integration, dynamic planning and execution. So don't be overwhelmed with the kind of technology that is used here. So these all are what we are going to discuss in detail. So you have to now keep in mind, there is what are the different kinds of design patterns that are used as part of agentic AI. One is the reflection pattern. The other is the tool use pattern. The other is the planning pattern. We will see each of these in detail, so nothing to worry. So if you look at the workflow of an AI native architecture, there is a adaptive workflow, a continuous feedback loop, evolving outcomes, dynamic learning, and then going back to adaptive workflows. So this goes in an iterative incremental loop in order to get the results for a complex systems. So if you look at the key traits of AI agents in terms of autonomy and social ability, so if you have high autonomy and high social ability, it is falling into multi-agent systems. If you take very low autonomy and low social ability, they are falling into rule-based systems. So rule-based systems are on one part of the diagonal, whereas your multi-agent systems are on the peak of your diagonal on the right side. So the other two sides, you have your customer service chatbots and your self-driving cars. The self-driving or autonomous cars, where you will not even need a driver, is on the side of a high autonomy and low social ability. So if we look at the AI agent models, initially they have divided them into reactive agents, deliberate agents, a combination of reactive and deliberate, which is called as a hybrid agent. So in reactive agents, the inside black dot is the reactive agent. So the definition of a reactive agent is that the agent responds directly to environmental stimuli with or without reasoning. What are the features of the reactive agents are simple and fast decision making, lack of long-term planning. One of the examples of a reactive agent is a reflex agent like game bots reacting to player moves. So you can imagine a reactive agent to be like having a generative step and then a reflection of what is generated, trying to correct it and then give a feedback loop back to the user. That is a reactive agent. A deliberate agent, on the other hand, it is coming into the second concentric circle here. So it is agents that use reasoning and planning to achieve their goals, maintains an internal mode of environment, use goal-oriented behavior in decision making. Examples are route planners for navigation systems. So anything that needs a planning, a pre-planning before execution, you can know the different kinds of steps that you are supposed to execute. For example, route planners, you can know that what is the route that you need to take. If you have to go from node 1 to node 10, you plan it ahead and then you execute. Those type of agents will fall as deliberate agents. What are hybrid agents? They're a combination of both reactive and deliberate agents. So hybrid agents that combine the reactive and deliberate approaches leverage the benefits of both. They are reactive for immediate responses, deliberate for complex goal-oriented planning. What are the examples of hybrid agents? Autonomous vehicles. So react to obstacles in real world while planning long-term routes. So our autonomous self-driving cars are an example of hybrid agents. So when you look at AI agents in the long, even before our generative AI came into picture, we can classify them as utility-based agents, goal-based agents, model-based agents, and simple reflex agents. Like I told you in the same concentric circle, the simple reflex agents have no memory, highly reactive but limited in scope. If you look at the goal-based agents, they uses planning to determine the optimal actions, focuses on achieving the outcomes than responses. Then we have the model-based agent. It incorporates memory to predict future sales and can handle partially observable environments. If you take the utility-based agents, they measure the utility to rank possible outcomes, select actions that maximize the overall utility. Yes? Sorry, any question? I heard some noise. Okay, so I'll go ahead. So even before the advent of generative AI, there were these kind of agents: simple reflex agent, model-based agent, goal-based agent, and utility-based agents. So the main strengths and limitations of these is that they have predefined rules and they had internal memory and history. They had objectives and planning. The main limitations were around adaptability, computationally intensive, lack of efficiency in decision making, and they required detailed utility-based models. So with the invent of generative AI, what happened in the AI agents is that we have come up with all of these kind of key features and considerations that had a very transformative impact. One is in terms of content generation, contextual understanding, multimodal capabilities of the models that are built in terms of handling both text, videos, audios, and so on, emergent reasoning in terms of problem solving, logical analysis, interactive workflows, scalability. So some other considerations for generative AI are that we have to be having ethical consideration, bias, privacy.
ma'am, good evening, ma'am. 2 minutes பேசலாம் ma'am.
சொல்லுப்பா.
Misuse.
ma'am,
Can you please go on mute?
என்னன்னா
Mute.
போயிட்டு இருக்குல்ல மேம்.
ஆமா.
இப்போ எல்லா டிபார்ட்மெண்ட்லயும் லாஸ்ட் 2 years வந்து ஆள் தரலன்னு சொல்லிட்டு நான் என்ன பண்ணேன்னா ப்ரேயராவே ஒரு 10 days பிஃபோர் வந்து நான் ஃபார்ம் பண்ண வச்சேன் மேம் பசங்களை. இப்போ என்ன ப்ராப்ளம் பண்ணிருக்காங்கன்னா நேத்தா ப்ராப்ளம் ஸ்டேட்மெண்ட் ரிலீஸ் ஆச்சு.
Dear participants, kindly mute yourself. Participants,
டிபார்ட்மெண்ட் ஃபேக்கல்டிஸ் என்ன சொல்லிருக்காங்க, ஒருத்தர் இருந்தாலும் நீங்க தான் டீச்சரா இருக்கணும், எனக்கு போகாதீங்க.
Ma'am, I think you can make them all mute, ma'am. You can mute
no,
it.
I'm trying, ma'am. I'm trying one second.
Muted everybody.
Yes, ma'am. Ma'am, Anita, ma'am, Adi, ma'am also muted.
Yeah. No, I was able to unmute myself. Thank you so
okay.
much. Ma'am, whenever you find there is a noise, maybe you can try to mute. I will try to unmute.
Yes, ma'am. Thank you.
Thank you so much. Yeah. So coming back,
One
so with
more
the
thing.
advance, yes,
Adi ma'am, kindly can you make your screen in a bigger mode, madam? Like participants are saying that they are unable to see the full screen.
Ma'am, I have put in full screen mode only. I'm not sure.
Ma'am, it is in full screen only, ma'am.
It is in full screen, pa. This RTT is not making the people.
They can make them pin. They can pin, madam, so that they can view for the entire screen.
People, participants, kindly make madam pin, or else you can also increase the size of the screen which is visible. Under Adilakshmi ma'am, you can have the plus option or full screen option is there. Kindly make like such and make it visible your slides.
Yeah, you can make her in a pin mode. Pin her and then you can see.
Yes,
okay,
ma'am.
people. Okay, ma'am.
I have actually tried to remove my video also so that I'll have faster and so that I have my entire screen.
Yeah, it is visible.
Yes, ma'am. So with the advent of generative AI, so what happened is in terms of context generation, contextual understanding, and multimodal capabilities of the LLMs that we have, there is a lot of changes that happened in agentic AI technology. And with the emergent reasoning, interactive workflows, and scalability, we are able to bring the AI agents from a kind of one range to another. So the new paradigm, the Gen AI transformed the AI agents. So how it has transformed is in all of these aspects. In the traditional agent limitations, we used to have fixed rule set and static models. The rules, it was like if then else rule statements, and the models were kind of static. We had a limited contextual understanding of the subject. We do not know much beyond what was there. There were inflexible decision processes, poor adaptation to uncertainty. So all of these things have been overcome with the generative AI. Now we have dynamic solution generation, a context awareness, interactive learning, and multimodal capabilities. So when I say dynamic solution generation, the environment will be kind of a reinforced environment where there are sensors that can capture. For example, if you are looking at a weather, you are having weather as part of your information and you are doing a traveling. You're building a traveling app, right? It is continuously sensing the weather and it is taking a decision depending on the weather is sunny or cloudy and making your travel plans accordingly. So that is what is meant by dynamic solution generation. Contextual awareness is having a context of the application that you're trying to build. If you are building something in terms of legal application, then you are having all of the documents that is required, the legal documents stored in your databases. That is contextual awareness. Interactive learning is like the user is able to give a prompt in such a way, and the output in an iterative loop goes on and on until you get the required desired outcome. So it's kind of interactive in that sense. The multimodal capabilities of the LLMs, like being able to handle text, audio, video, and all different types of files, are giving uh, huge amount of processing capabilities for the agentic AI. So now what I'm trying to tell is that there are some agentic AIs already existing with the advent of generative AI, and there are these design patterns. So what are design patterns? Design patterns are reusable solutions which are in terms of common problems in software design. For example, in terms of consistency, efficiency, promoting modular, scalable, and maintainable architectures, these are kind of frameworks that we can apply. So in agentic AI also, these design patterns have been applied to agentic AI frameworks with the advancements of the generative AI technologies in bringing up certain agentic AI design patterns. That is what I'm going to talk about now. So in this particular role of design patterns, what is the main advantage of design patterns? We are able to simplify complex problems, encourage code reusability, and improve the collaboration. So what is the relevancy to AI agents? We have seen that these three concentric circles. So the relevancy to AI agents is in terms of scalability and modularity, where multi-agent collaborations will ensure a distributed systems. It will support the seamless integration and calls of APIs. There is autonomy and adaptability. It will require the design patterns to support the decision making. It will also be able to handle complex workflows in terms of design patterns and balance reactive and deliberative behaviors with hybrid approaches. So why are we using design patterns for agentic AI solutions? It is in terms of reusability. That is, we are able to apply proven solutions to complex agent architectures. In terms of efficiency, reduce the development overhead by leveraging the established practices. In terms of reliability, building systems with robust tested workflows that adapt to changing environments. So now, so in all of these aspects, the design pattern solutions works. Even though there are some limitations, we can see what are all the design patterns that we have for each of these particular challenges. In terms of complexity, we can use a tool use pattern. Okay, we have to remember this particular thing here. In terms of complexity, whenever the use case is complicated, we have to go with a tool use pattern. That is the very important thing. In terms of scalability also, we go with tool use pattern. In terms of adaptability, we go with a reflection pattern. In terms of reusability, we go with provide reusable frameworks. It can be any of these actually, a combination. In terms of tool integration, we again go with tool use pattern. In terms of multi-agent collaboration, we go with multi-agent patterns. So overall, with the advent of Gen AI and the combination of design, software design patterns, we are able to come with 4 different kinds of AI agents. What are those 4 agents? I will let you know. So the evolution of design patterns is from the Alexander's pattern language to now the current 2000s AI application and pattern development. So these are all the architectural components of any agentic AI. So whenever you're trying to give an architecture for an agent, you are having an input layer in which the input layer is having a user prompt. It will detect the intent, and it has some kind of sensors as well. You have a control flow and decision engine where this is nothing but the processing layer. Then your input goes to the processing core framework where you have reactive workflows generating critic and iteration. Then your input goes to the integration layer, wherein it goes to a communication layer, and then the output layer. So we'll take an example. Here we can take an example of an customer support chatbot. If you're looking at a IA help desk, it is nothing but an intelligent automation help desk in any industry. So what happens is there are people who are sending, they have queries around their invoice, for example. So user will send an email to the help desk team saying that, okay, tell me the status of my invoice or my order that I placed recently. So what happens is that whenever you are replacing with an agent, right, it has all of these layers. We'll look at each of them in terms of a help desk. So intent. So it is trying to capture the intent of the particular user. It will identify for what the email he has sent. Depending on the head of the email and the body of the email, using NLP techniques, right? We are going to process the text and understand what is the intent of the user. And from there, what happens? Control flow and decision making, depending on what he has asked. If he's asking for an invoice, I take only two scenarios here. One scenario, he's asking for an invoice status. Other scenario, he's asking for a invoice status. The other scenario, he's asking for a resetting of his password, say for example. So in both of the scenarios, it has to capture the intent. Then it has to make a decision. If it is a reset of a password, it will have to call again an API call in order to send a user a reply back to the user to reset his password. If it is an invoice status, it may have to make an API call in order to go into the ERP system or the SAP flow, process the information in the SAP, integrate it, and then bring it back to the communication layer and send a reply back to the user saying that your invoice is in so and so status. Okay, so depending on what type of request has been sent by the user, we are going to use each of these particular boxes that are there. This is a generic approach for any AI agentic architecture. So now you are entering to the crucial part of the agentic AI design patterns. So by the end of the session, I want you to remember all of these 4 patterns. So what are the agentic AI design patterns? Reflection pattern, tool use pattern, planning pattern, multi-agent collaboration pattern. Now, in the next 20 to 30 minutes, we'll be going into each of these patterns in detail, like what is it and why are we using it and what are the applications, real world applications of each of these. Okay, so first we will start with the reflection pattern. I will take some time to spend on this particular site so that you are aware of what is a reflection pattern. So in a reflection pattern, what happens is that always I told you, we will look at the diagram here in order to understand what is a reflection pattern. So imagine that this is the this symbol is of an chat OpenAI, ChatGPT OpenAI call. Whenever a user, say for example, this lady over here is sending a prompt to the ChatGPT. It's asking like, okay, tell me how is the give me a report on it is asking on whether I can uh, whether I do not have any agreement prepared for rental agreement prepared. Can you let me know if it is legally okay or not? So some user is typing a prompt like that. Okay, it goes to the GPT 4o, and then in a reflection pattern, what happens is, yeah. So whenever in a normal GP, whenever you are using your chat GPT, the response comes immediately back to you. But when we are coding and using a reflection pattern, what happens is that when the user sends a prompt asking that I am not having a legal agreement for my rent, is it okay? So what happens is that it will send the GPT will actually take the response from the user. It will prepare the output text and it will reflect on the output that is generated. So there are two brains. Whenever there is an LLM call, imagine that to be the brain. Okay, so there is a generation phase and there is a reflection phase. It reflects on the output and it will think, it will keep asking questions like, did I cover all aspects? Did I take into account all the other regions that are there as well? And so it will try to, if the answer is no to any of those, it will again reflect on the answer it has generated and then it will refine its own answer. So it goes in an iterative loop here until and unless it is not getting the required or the desired outcome. What is the desired outcome? The desired outcome is that we need to tell in all the different provinces in India whether having a rental agreement or not having a rental agreement will get into any legal complications or not. That is the question. So only if it has answered in only one particular response back, it would not have been a correct one. It is not covering all aspects of the answer, but it will go into an iterative phase where it will reflect on the answer, revise itself. It will go in a self-critic mode, revise its answer, again generates the answer, and so on, maybe 10 times, 20 times, 30 times. So everything will be like an LLM call. Ultimately, it will be generating cost also. So we can actually fix the number of times is iterate depending on the output. Whenever we get the desired output, we can stop it. Or we can say that run for only 3 iterations or 4 iterations and so on. So we can fix the iteration in 2 aspects. Either we can give a number or a counter, or we can, until the desired outcome is achieved, we can keep on asking it to repeat. So reflection pattern is quite simple. So what happens? There are 3 stages here: generation stage, reflection stage, and then there is a self-critic and an iterative refinement over a period of time. So if you see the components here, generation phase, reflection phase, and an iteration phase. Incremental improvement, enhanced adaptability to complex tasks. So keep this reflection pattern in your mind. We are going to the next one, tool use pattern. So in terms of tool use pattern, let us look at this diagram in detail. We'll spend some time understanding what is happening. So in the last one, in a reflection pattern, what happened? The user was sending a prompt. The user is able to get the output only when we feel that the desired outcome had come back. But here in a tool use pattern, what is happening is the user is setting a prompt, and depending on that, the particular tool use pattern agent is calling multiple tools, tool A, tool B, tool C. And at the end of every tool is generating a response back to the user. This is called as a tool use pattern. I will give you an example for better understanding. Say, for example, if you are designing a travel application or a travel app, and you are using agentic AI workflows. So it's a very complex and sophisticated design, personalized design in such a way that you will be able to have weather information. It will actually take into account your flight booking. It will also take into account your accommodation and food. So all of these you can take as for weather. It will go into weather. Some app you are calling. A weather API it is calling. In terms of food and accommodation, it is calling one other API. In terms of flight booking, it is calling maybe make my trip or something like that. So different tools are involved in the entire process, and a combination of all of these is going to be coming back to the user. So tools can be anything as simple as a calculator to as complex as calling an API call. So main thing that you need to understand is the components here are tool repository, a selection mechanism of the tool, and the execution mechanism. So I'll go to the next one, which is nothing but the planning pattern. So here, whenever a user is submitting a prompt, so we have a planning. The planning agent will make a list of all the different tasks that are to be happening in sequence. It will generate the tasks and it will execute them one after the other using React and Revue frameworks. I will talk about this in a bit later. And then it will replan and iterate this over a period of time until it requires the desired outcome and send the response back to the user. What are the core components of a planning pattern? Tool planning, task execution, and replanning. So what are the benefits here? Dynamic adaptability and optimized task execution. Let me give you an example of a planning pattern. For example, whenever you have to, the same trip advisor, whenever you want to make an app as a traveler app, what you can do initially is that you can make it like a planning agent in which it will give you all the 4 steps. First one, make an itinerary take the required data collection. Second step, make a travel itinerary plan. So, third step, call the required tools and APIs in terms of weather, food, flight booking. Number 4, feedback, capture the feedback of the user and send it back. So it will make a plan and execute. The main point that you need to remember here is that there is not always, for the same use case, you are not always following planning or a reflection or a tool use. You can have a combination of this. For example, in the travel app that I am talking about, right? You can have a combination of reflex pattern plus tool use pattern plus planning pattern. So it will not be, it can be one or it can be many. That is the main point that you need to keep in your mind. So the next one here is the multi-agent pattern. So if you look at the diagram here, the user sends a prompt to the agent. Here there are different agents here, agent 1, agent 2, agent 3, agent 4. The agent 1 is responsible as a software engineer. Agent 2 here is a project manager. The agent 3 is a content developer. The agent 4 is a market research analyst. So what will happen here? You can imagine that the software engineer who is sitting here may act like an orchestrator agent. He will orchestrate. Each of the agents is given a task, one specific task. So each of the agents will perform their task, and the orchestrator agent will actually capture the outputs of each of the other agents, and it will finally integrate and orchestrate the outputs, send the response back to the user. This is a typical multi-agent collaboration. So what happens in this particular thing is that there are communication protocols that happens between the agents. The task allocation happens between the agents. Sometimes it may happen in terms of conflicts also, and we need to identify conflict resolution algorithms and advanced protocols in that aspect. But the major benefits around multi-agent collaboration is scalability, problem solving, fault tolerance, and decentralization. So there can be a combination of multi-agent collaboration with each of these as well. The reflection agent, the tool agent, and the planning agent as well. So what are some of the use cases of AI design patterns? Like I told you again, it can be a reflection pattern, it can be a planning pattern, it can be a tool use pattern, or it can be a multi-agent collaboration pattern. In terms of reflection pattern, you have to keep in mind what are the most common use cases of reflection pattern. Text generation, okay, that is nothing but content generation, code generation, problem solving and reasoning. We will have a use case. I have a case study with regards to this. There is a tool use pattern. In the tool use pattern, you have an automated data analysis, a leverage statistical tools to diverse insights, which means that we can use a tool use pattern for our data analytics use cases or for our data modeling. That means all of the entire process of a data scientist, right? In terms of data capturing, model building, deploying the model, the CI/CD pipeline, right? Entire thing can be made as a tool use pattern for all the different tools that we are using. The planning pattern, right? The planning pattern is in terms of whenever you are having any kind of a sequential workflows in industries, you can go for a planning pattern. For example, task organization in personalized productivity tools or autonomous robots in manufacturing. These are the typical use cases of planning pattern. In terms of multi-agent collaboration pattern, real-time fraud collaboration in cross-border payments, and multimodal customer service in e-commerce. The IA help desk that I have been talking about, right? It will come as a multi-agent collaboration pattern. What happens is that you can imagine whenever there is a person who is trying to answer your query, if you're trying to call Airtel subscriber saying that your landline or your internet is not working, you can imagine in another 1 or 2 months time that an AI bot will be talking to you saying that, hi, so and so, I understand your request. So I know you have had a problem that the internet is been down quite for some time. We are resolving the issue. This issue is there in your area. From the last 2 hours, we will be getting back to you in another 2 hours time. So all of these things are happening with the help of multi-agent collaboration pattern. The moment you raise a ticket, the bot is able to understand what it is about. It is able to go and make an API call and access the information of your account, saying that, okay, you are like a very potential user, you are using all of their services, and we need to respond to you back in the given SLA time of 3 hours, and it's going to respond to you. The text is placed there, the text is converted to speech, and then you're going to get an answer back within 3 hours, and it is going to resolve your issue as well. So that is the kind of automation that we are looking in terms of agentic AI design patterns. And the multi-agent collaboration is one of them. It's having a combination on all of this: reflection pattern, planning pattern, and tool use pattern. These are the main topics. And now I'm going to discuss in detail what are the architecture of each of these in detail. So now we look into the reflection pattern. As I told you, a reflection pattern is a design pattern that will enable the AI systems to alternate between the creation, and it will act as a critic. It can be a self-critic, and it will foster for an iterative improvement. That means you're having these three circles here. It will create or generate, it will critic, it will make a self-critic, It will iterate to keep improving itself over a period of time. And then finally, it will send the response back to the user. So what are the core concepts in terms of reflection pattern? You have create, which will draft the content and generate the code. You have a critic phase where you will assess the quality and the find issues. And you have an iteration phase where you will refine your work and fix the problems. So what are the most important reflection? Why is that the reflection pattern important? For some number of reasons. Because of the adaptability, improved accuracy, correction, AI assistant writing, code debugging, and in design tools. So we have an AI assistant writing as well. Okay, so we can make, when you wanted to build a AI agent for content generation, say for example, you have around 200 research papers and you want to have a summary of all that so that you can prepare your literature survey. What we can do is we can have two agents there. One is a data collection agent. The other is an analysis agent. I think you can have three agents. One is a data collection agent. The other is an analysis agent. The other is a reviewer agent. So using these three combinations, you can get an output where you are having a summarized content of all the 200 research papers so that we can straight away use them for our literature review. So that is one of the use cases. So we have already looked at this one. So why is that the iterative in all of the reflection pattern, right? The main thing is the iterative workflow. It goes on and on for 10 times, 20 times, 50 times. So why is that we are having this iteration? Because to break down the task into manageable cycles of creation, evaluation, and refinement. So what are the benefits of iterative workflows? Adaptability. So what do you mean when you say adaptability? Example is a chatbot iteratively improving responses based on the user sentiment. If the user sentiment is bad, right, it will take the feedback and accordingly it will improve its response. In terms of error reduction, whenever you're making a software, right, and there is a debugging software through multiple refinement loops, right, you have an error and you will be able to run your iterative loop until you fix the error. That is for the error reduction. Incremental improvement. You have an AI assisted content generation, which is refining the draft to meet the design, tone, and style. That's what I told you in terms of literature review document. So efficiency in problem solving. So iteratively improve the machine generated designs in engineering workflows. So what are the real world examples of iterative workflows? Let us have a look at some of the, I will look at some of the examples later. Now, if you see, what are the main benefits of using the reflection pattern? Incremental improvement, error correction, efficiency, and broader applicability. Okay, so what you need to understand here is these are kind of repetitive. You need to understand that what is the importance of this incremental improvement in the reflection pattern. You generate the output, you are acting like a self-critic and you refine based on the self-critic. You repeat the process, you generate the output, the loop goes on until you get the desired outcome. It is kind of the same thing that you're telling over and over again. So what are the advantages of the self-critic? It is in terms of accuracy, flexibility, and efficiency. So why is that that dynamic and resilient AI important and adaptability matters? Mainly it is because in terms of the customer preferences in an automated service system changes frequently. That is why you have to have a reflection pattern. So this is a very, very, very important point. For example, if a bank, suppose you are having a banking system and we are trying to automate the banking system help desk with the help of an AI agent, we need to understand that the requirement of the customers will change over a period of time. What used to be the requirement yesterday or 2-3 days will not be the requirement today or tomorrow. Okay. For example, people who used to use the chatbot 2-3 days before, banking chatbot, to know the account status or their the summary of their the balance, account balance. Now today they want to come and check why are the UPI payments failing. They want to have a dispute resolution on the UPI payments. They want to know the status of their home loan application. So depending on what they are coming today, we need to dynamically change depending on the customer preferences. That is the capability of the current AI agents, which is not there 2-3 months before. So how does the reflection pattern drives? This is mainly in terms of the feedback integration. Whenever the customers are giving feedback, right, we are able to incorporate that and make the changes dynamically. Scenario specific adjustments. We can also make, suppose if you are designing AI agents for specific Indian region, you have made an AI agent for India geography. You want to deploy that in US. We can make it within no time. You can change the region and get that deployed. That is the one of the example for scenario specific adjustments. Scalable learning. Okay, so in terms of adding number of users and in terms of the documents that they process, it's immense computational complexity. So what are the benefits of this adaptability? We have user-centric outputs, operational resilience, and longevity. So we also wanted to focus on the error correction. In a reflection pattern, what is happening is that it is correcting the error by itself. How is it able to do that? It will identify the issue, it will apply the fix, review the results, and reduce the errors. So in this particular iterative fashion, it will iterate over a period of time to correct the error by itself. So with the use of the error correction, it will iterate over a period of time and it will be able to give you a solution for a complex design environment. So what are the uses of error correction? Precision, efficiency, and trustworthiness. So you have to concentrate on this particular task. There is an error correction layer and an adaptability layer in the reflection pattern. So the AI agent is sitting in the core of that. The error correction is having certain of the code debugging, content editing, quality checks, and logic validation. The adaptability layer has something like dynamic task adjustment, workflow optimization, resource allocation, and strategy refinement. So we are going through each of the steps of reflection agent. What did we talk about the reflection agent? We have a generation step, and we have a reflection step, and we have an iteration and refinement step. Now I want to bring all of these in one particular slide here. Okay, for a generation, reflection, and an iteration, right? What is happening? You have an input. The common things are input processor, generation engine, and a validator. So, each of the phases, what is happening is that it is going to take your initial input, provide the feedback, refine the requirements, and improving over a period of time. I don't want to spend much time on the reflection agent. I want to go to the real life examples of reflection pattern. So everyone can relate to this. Research paper summaries. Whenever you want to prepare a summary of your research paper, like a literature review, always try to use a reflection pattern AI agent. So it has a generation phase, critic phase, and iteration phase. The second best example of a reflection pattern is text generation. Whenever you want to produce any article, essay, or an instructional design material like a PPT, you can use this particular reflection pattern. Like how we have talked about, it has a generation phase, critic phase, and an iteration phase. What is the other best example of reflection pattern? Debugging. Whenever you want to debug your code and your code has errors, you can go with your reflection pattern again. What are the other advanced applications of reflection patterns? Report generation, query optimization, and test case creation. Now we are going into the next set of AI agentic pattern, tool use pattern. What is a tool use pattern? Like I told you, making API calls, different API calls in order to accomplish a task. For example, I want to build a travel app where I can travel my entire itinerary. I will be building a tool use pattern because I will be able to get the weather update. I will be able to book my flights. I can book my hotel accommodations. I can book my restaurants. I can get the feedback. I can get all the different coupons and with the minimum cost. And finally, I will get the feedback from the user on how it is doing. So all of this travel itinerary plan can be used with the help of a tool use pattern. So in a tool use pattern, what you have to mainly look at is what are the steps that are there in a tool use pattern. Okay, like I told you, the user task, plan my trip to New York, traveling plan. What is the AI agent doing? Identify the tools. You have a weather API, you have a flight search, you have a hotel booking. You integrate all of this particular response and the combined travel plan is sent back to the user. So why we want to go with a tool use pattern? It will extend the AI functionality and it will enhance the scalability. Previously, whatever was not possible, right? We were not able to make such a seamless API calls. Now, with the help of tool use agentic pattern, you will not be even knowing that we are making an API call to some other Salesforce application or an ERM application or a CRM application. You are seamlessly able to make the calls and get your outputs done. So what are all the key features of a tool use pattern? Task identification, tool selection, execution, and integration. These are all the steps that you need to remember in a tool use pattern. Just like for reflection, you have generation, reflection, and iteration, right? You have task identification, tool selection, execution, and integration. So what are the current limitations of LLMs? The LLMs, instead of using the LLMs, why are we going with agentic AIs? Because LLMs, they have only static knowledge. They are only trained on certain amount of information. They do not know very specific information. And the lack of real-time data, limited functionality. Because of all of these dynamic integration with real-time tools, extending functionality beyond core capabilities, modularity and scalability. Because of all of these limitations of the LLMs, we are going with the tool use pattern. So what are the advantages of tool use pattern? We are able to generate real-time insights, expanded versatility, and adaptive learning. So the main advantages of a tool use pattern is in terms of modularity, adaptability, and real-time integration. What is modularity? You're able to build your applications module by module. Okay. For example, you're adding a new API for traffic updates on an existing traveler assistant. Okay. If you're able to know where there is heavy traffic and where there is left traffic, that is how you are modularizing your code. In terms of adaptability, if you have a chatbot, right, you can switch between the API calls. Suppose, for example, in India, we have different languages. Depending on the state from which you are asking, when you're asking from Andhra, it gives you in Telugu. When you're asking from Tamil Nadu, it gives you in Tamil. So dynamically, depending on your region, it is able to switch the language by using the APIs, Google Translate APIs. So real-time integration, you're able to integrate real-time with the weather updates, flight accommodations, the travel itinerary plan, and so on. So we want to see architecturally what are the core components of a tool integration. These are the core components of a tool integration. The core AI system, tool repository availability via APIs and services, selection mechanism, and tool execution. You have to remember all the 4 components. So what are the agentic aspects of the tool use pattern? What are the things that it is bringing into picture? Autonomy, reactivity, proactivity, modular collaborative, and iterative adaptation. So one other thing you need to remember is that tool use pattern is used in terms of sequential workflows. Whenever you have a sequential workflow that is happening one after the other, right? For example, a step-by-step approach where the tasks are to be processed in order and where decisions have to be made at each and every step, right? We are using the tool use pattern. So you have to remember whenever there is a task decomposition and tools that are used, right? We go with the tool use pattern. So some of the examples of sequential workflows are logistics management, the education, the wellness, health wellness. In terms of wellness, whenever you want to have a fitness plan for yourself, right? They try to track your metrics in terms of how is your heart rate, how are all the vitals doing with the help of the smart watches that you're wearing, in terms of the exercise activity that you're doing. They process it internally on the edge devices and they give you back your fitness plan depending on your current situation. So this is an example of a sequential workflow health plan that you can do with the help of tool design. So what are the architectural elements of a tool design? Like I told you, input parsing, tool repository, tool selection. There is an integration layer, execution, and feedback. So I have 2 good examples about the tool use pattern. If you have a look at this one, you will be able to understand very well. So the user will send a query asking, what is the weather like in New York tomorrow? So what the input, it is being divided into intent and parameters. The intent here is that you need to know the weather forecast. What are the parameters here? The location is New York. The time is tomorrow. You wanted to know for New York location, tomorrow, what is the weather forecast? So there, what will happen? It will check all the available APIs. One is a weather API and open weather. 2 APIs are there with regards to the weather. So it has run on all the 2 APIs. and it has got the responses also. The response time for the weather API is 150 milliseconds. The response time for the open weather is 250 milliseconds. Accuracy, weather API 95%, open weather 92%, which is better here. Weather API is better. So therefore, what is it doing? It is selection the tool as weather API. And in the execution, it is making a get request for the weather API, and the chatbot response is sent back to the user saying, the weather in New York tomorrow will be partly cloudy with a high of 18 degrees centigrade. So this is how the agentic chatbots are working in real time. So what is this pattern called? It's a tool use pattern. So one other example is in terms of e-commerce. You're asking, is the blue wireless headphone in stock? Can I get it delivered by Friday? What we are doing on the query, there is an NLP query, right? You process the natural language, you understand the intent, you understand the product, you understand by when you are required to deliver that, you understand what are the actions that you need to take on that, stock checking, delivery check, and so on. So you do a parallel execution run. What are all the API calls that you have to process here? You have to do an inventory API, you have to do a shipping API, pricing API, you have post and get responses here. All the responses you are integrating together to give you the response back. So this is happening in terms of an Amazon e-commerce chatbot agentic AI application. So now we are entering into the third one. So till now, how many patterns we have seen? We have seen a reflexive pattern. We have seen the tool use pattern. Now we are seeing the planning. So what is happening in the planning? Okay, so planning pattern, what are the key components? Deliver a report summary sales data by Friday. Okay, how do you decompose the task? Collect the data, analyze the trends, draft the query. So what we have to remember is that a planning pattern is used whenever there are a sequence of steps that have to happen and you plan them ahead. Okay. And there is a dynamic reasoning and a real-time adjustments that you can do on the planning pattern. As I told you earlier, all the agentic AIs are coming with the autonomy, adaptability, and scalability features. These are common across all agentic AI patterns. So what are the real-time use cases or applications of task planning? AI-powered research assistants. Whenever we want to do research, right, we can query the databases, we can find the summary of the findings, group them by themes, write a draft, format and refine. We can use them for e-commerce personalization chatbots, autonomous customer support, which is nothing but the help desk that I'm talking about. ATAL help desk, right? So, okay, here the important thing that you need to remember in the planning pattern is that we have two frameworks. One is React and Review. React is nothing but reason, act, and observe. It will act in a loop, and it is happening on a gradual basis. Review is another framework that is like planner, worker, and solver. It happens in a batch mode, and both are agentic. So depending on what is the application, you will select it as a React or a Review framework. So I have three different examples here. Suppose you have a meeting scheduler. Okay. You can actually go with a React pattern or a Review pattern. The main criteria that you need to fix is that the React is best for immediate scheduling needs, whereas Review, it is optimal for complex long-term scheduling workflows. Okay, so everywhere, wherever you need to have an immediate scheduling need, you go for React. Whenever you have a long-term complex workflow, you go with Review. Okay, whenever these two are coming under the planning agentic patterns. The second one is the GenAI powered warehouse robotics architecture. So one is an individual robot control center. The other is a fleet orchestration. So in both of these again, whenever you want to go for an immediate scheduling needs, go for React. Whenever you want to go for complex long-term scheduling workflows, go with Review. The last and final example in the planning agent is the R&D systems. Suppose you want to have individual project focus, go with React. If you have an organization-wide orchestration, go with Review. So whenever you have an multi-project coordination and multiple resource management rights, you have to go with the Review framework. Now we are entering into the last and final agentic AI pattern, which is nothing but the multi-agent collaboration pattern. The multi-agent collaboration pattern are coming with a React framework. Okay. What are multi-agents? Multi-agent patterns refer to the frameworks or architectures where multiple autonomous agents collaborate to solve complex tasks. Why are multi-agent patterns essential? Because of the complexity that we see in the modern systems, right? And the dynamic and uncertain environments, like I told you in regards to the traffic, in order to know the traffic updates, weather updates, right? We can go with agentic AI patterns. As I told you earlier, agentic AI pattern can have a combination of a reflection pattern, tool use pattern, and a planning pattern as well. So in multiple agent patterns, right, we have distributed sources of data. So distribution across warehouses, supply chains, and cloud infrastructures are all like adherently distributed. In terms of scalability and modularity also, multi-agent patterns are always better than single agents. So what is the limitations of single agents? It is lack of scalability, single point of failure, inefficiency in the distribution, limited adaptability, and computational overhead. How we can have multi-agent solutions? They are decentralized, resilient, we can have parallel processing, and we can have local adaptability. So in multi-agents, right, we have to go with distributed intelligence. What is distributed intelligence? Multiple autonomous agents are working together, sharing information and collaboratively solving tasks with decentralized intelligence. Okay, what are some of the use cases of distributed intelligence with multi-agent patterns? Smart cities, cloud computing, healthcare system. What are some of the collaborative agents in action? Okay, autonomous systems working together, combining the local autonomy with global coordination are some of the examples. So there are SWAM robotics. What is SWAM intelligence and robotics? Whenever you are using SWAM intelligence, right, for your robotic applications, it will come into SWAM robotics. You have distributed decision making, you have environmental monitoring, you have healthcare coordination. So in all of these current scenarios, you have collaborative agents working in action. So what are the advantages of single agent versus multi-agent? As I told you earlier, single agents have all tasks are performed sequentially, limited scalability, vulnerability, centralized, and communications are very poor, slower, and simpler. In terms of multi-agent, right, the tasks are distributed across agents. They are highly scalable, robust, decentralized, highly optimized for distributed resources and tasks. They are faster agents and more complex coordination among the agents will be required. So we have already seen in all of these, right, how multiple agents are better when compared to single agents. So there are three parts here. One is in terms of the cooperative collaboration and competitive collaboration. There are two aspects here. One is the cooperative collaboration. How are we doing in terms of collaboration with respect to having multiple agents, having implementation insights? So successful cooperative collaboration will require communication patterns and implementation strategies. If you look at competitive collaboration, right, they will require careful balance of rules and constraints. So we should have a balance of both cooperative as well as competitive collaboration in terms of multiple agents. It should come with a hybrid collaboration. So how is it making it optimal? It will make a balance between the system efficiency versus the individual performance. So what are some of the messaging protocols that has to happen in terms of multi-agents? We know that in multiple agents, right, there are different agents that are doing individual tasks. We need to have a methodology of communication where we are able to pass the information. So we have message queues, asynchronous, direct calls. We can publish and subscribe system, and we have an event-driven communication and a shared store. And with the help of agentic AI and generative AI, right, we have context messaging, adaptive protocol selection, feedback loops, dynamic content generation, and real-time adaptation as well. So in terms of an GenAI enhanced agentic communication, right, the main things that we need to understand here in terms of the communication layer. So in terms of message understanding, with the help of LLM models, we can improve our accuracy to 97%. and we have a protocol adaptation. We have 12 plus protocols in terms of the bridging, and the latency is less than 20 milliseconds. In terms of the conversation management, we have memory, which is capturing 1 million states, and we have a coherence of 99.2%. So that is how our LLMs are able to improve the agentic AI multi-collaboration performance. When we are coordinating the mechanism in multi-agents, right, we have two different agents. One is a supervisor agent, who is a centralized control, and we have a decentralized control. In terms of a supervisor agent, what happens is that because we have a centralized control, there is kind of task assignment and conflict resolution that happens. In terms of decentralized control, we have high resilience, we can make local decisions, and it's a scalable architecture. So in terms of the multi-agents, right, in terms of traditional Gen AI and in terms of enhanced Gen AI, the difference is that the traditional was rule-based, whereas in Gen AI, it's contextual. In traditional, it's static task assignment. In Gen AI, it's dynamic resource allocation. Here we have limited communication in traditional. We have intelligent rich communication in agentic. We have rigid roles and we have adaptive roles. So I told you that whenever they have multiple agents in terms of the coordination, we may end up having conflicts. The conflicts can arise in terms of resources, the task, the goals, and inferences. So how do we coordinate all of that using some of these Gen AI enhanced algorithms like contextual insights, dynamic adaptation, proactive prevention, and generative solutions? So some of the task allocation strategies are centralized allocation, decentralized allocation, auction-based allocation, and dynamic allocation. So these are algorithms which will tell us certain advantages and disadvantages, right? The best among these is the decentralized allocation, where you can have everywhere the decision can be made, and then you need not depend on one particular supervisor. So what is the difference in terms of the Gen AI transformation of the multi-agent understanding? Previously, it used to be individual agent learning. Now it's collective learning. So knowledge synthesis, pattern discovery, and collective intelligence. So how Gen AI is improving the multi-agent learning? We have to remember the learning techniques here. We have the reinforcement learning, we have the federated learning, we have the imitation learning, and we have MARL, which is nothing but multi-agent reinforcement learning and collaborative learning. You can research on these topics for any of your problem statements. So what is the Gen AI transform for multi-agent architecture? So it has the real world impact in terms of autonomous systems, self-driving vehicles, in terms of robotics for manufacturing and logistics, smart infrastructure, urban systems, and spam systems. Now I have a case study. I want to show you one notebook where I will run one particular project. It has a developer agent and a tester agent. The main aim of the project is that I want to build a reflection pattern and a tool use pattern. Okay, so I'll go into the particular application. I will share this notebook with you, so don't be worried. We have 15 minutes more time with us. So let me explain each and every cell of this, and then I already ran this and kept it ready. So the only requirement that you need in order to run this particular Python notebook is that you should have an OpenAI API key. How do you get that? You go to the OpenAI, create an OpenAI key. So you can create a new secret key. You have to actually log into OpenAI, create a new secret key. I have already created the secret key. So in my Google Colab notebook here, so I'm actually building a multi-agent where I have a developer agent and a tester agent. I'll go through the code. The main thing here is whenever you create this API key, right, you copy the key, the OpenAI key, give a name, and then you copy the key, come back to your Google Colab, you click on this particular key option, and you give your key here. Okay, I have a Hugging Face OpenAI key also created. When you keep your keys here and I'm running the cells one after the other, right, it will get executed. Always you are supposed to give your API keys in this particular secrets only. So initially, whenever we are running any LLM or an agentic AI use case, right? So I am requiring LangChain OpenAI, LangGraph, and LangChain experimental libraries that are installed. Here, what I am doing in the first particular thing, I'm actually importing the OpenAI key here. I am using the GPT-4o mini. You can actually use with anything. You can use the turbo, you can use GPT-4o, 3.5, 3.5 turbo, any of that. So when I run the LLM joke, right? So maybe I can run one after the other. I will share this notebook with you. So don't worry on that. So it's taking some time to run. Meanwhile, I'll go through the code. So you have a look here. So the main thing that we are going to do here is that I have a user. He is submitting a request to the LLM GPT-4o. Whenever we have an LLM call, right, you always imagine it to be the brain. Okay. The first thing that is happening is that the user is submitting a request. What I want to do, I want to build a code. I want to make a developer agent and a tester agent. That means what? The LLM is actually generating a code in performing a certain, in making a certain game. Okay. And I'm actually having a tester agent which is testing the game also, like a reflex pattern. And until and unless I get that particular desire the game in a very good manner, right? I'm going to repeat this process. Okay. Generate the response, reflect, act like a self-critic, analyze the merits and demerits based on that, improve, again make a call, improvise your code, run and test it on the code. And then, so you have a developer agent and a tester agent. Okay, so this is executed. So here I have a question for you. What are the patterns that I'm using here? We have learned about 4 patterns: reflex pattern, tool use pattern, planning pattern, and multi-agent pattern. What are all the patterns I'm using here? Obviously, I'm using reflection pattern. Okay, because I'm iterating over a period of time. I am generating, I'm acting like a self-critic, iterating over a period of time. It's a reflection pattern. And any other patterns that I'm using? Any tools that I'm using? Actually, to be very precise, I am actually using a tool pattern also. I will let you know inside because I have a tool that I'm using. I'm using a tool to generate the code with the help of the LLM. So this is also executed. My OpenAI key is executed. Now, if I click on it, I just want to check whether the LLM call is working or not. Joke about AI agents. So it has run this. Now here I'm going to use the Python Ripple tool, which is used for generating the code. Okay, so if I run this and if I see, this is nothing but the developer agent design with the Python Ripple tool. Okay, so you are designing a developer agent. How you are designing a developer agent? You are passing an LLM call to the OpenAI. You are having a list of tools. Here the tools are only one, which is nothing but your Python Ripple tool. And you are having a string that is nothing but a prompt that you are passing. And the verbose is false. So you are having a developer agent. So all of these, see, developer agent, how we are passing. So you are saying this is the prompt that you are passing. We are saying that you are an intelligent coder who is well trained in writing a Python code. So when I run this, right, developer agent, what happens is that it is actually making a developer node as well. We are able to make the node with the help of LangGraph. We are using LangChain and LangGraph. I am creating a developer agent and a developer node as well. Now I am having a tester agent and a tester node as well. So I am running this cell as well so that I can show you the output. Then I have a shared graph. Okay, when I run the shared graph here, okay, this is nothing but the line graph. Okay, so when I run this line graph, okay, and I want to visualize the graph here. So you can imagine here, there is a developer node and a tester node. What we are doing, we are asking the developer node to develop something, and we are asking the tester node to test in all aspects. It will iterate over a period of time until we get the end result. Okay, so now what I am doing is that now I have run till here. Now what I want to do, I want to build a function called run reflection. For that, I am passing my graph. Whatever graph I generated here, I am passing, and I am passing a question, and I will ask it to run for some number of iterations. Say, for example, 3, 2, 1, or so on. Okay, so the run reflection function also ran. My aim here is to build a game so that we understand. You can do anything. You can generate anything. So for example, the question I'm writing here, write a Python code for the Flames game and give a complete executable file to test with 2 names as input. When I run this, right, see what is happening. I am running the function called run reflection. Here is the function that I run. Run reflection, I am passing the graph. Whatever question I have, I am passing, and I am passing the number of reflections. Reflections are 2. That is the number of times it has to execute. Okay, so here we say developer. What is the developer saying? He's actually generating the code and giving. Okay, he's giving you the entire developer code, and then in turn the tester is actually running. He's criticizing the code. So it is entering in a developer node loop and then the tester node loop. It will iterate for some time. Still, it is running actually. Until and unless we have a refined set of code, right? Keeps on running. For 2 times, it will run and stop. See, these are all the test cases that is getting generated. Revised Flames code. This is the second iteration. It has revised the code from the beginning and it has generated again. And then what is happening? Revised unit test code. The tester agent has given a revision and it is tested all of that. Okay. So now what we are supposed to do, it is done. Now what I will do is I will take the recent code. I will copy paste the code of the Flames and I will run it here. Okay. I will copy paste the developer code and I will run in a separate cell. Okay, so this is the entire function which is actually running something called as a flames. You must have known the game, right? There are 2 names if we give, we will know whether how are they related. Are they friends or lovers or affection, marriage, enemy or sister? Say for example, I'm asking for Romeo and Juliet or Devdas. Devdas is one name and Parvati is one name. So it will tell me whether how are they related to each other. It will tell me that the relationship between Devdas and Parvati is marriage. Okay. So this is one game. If you want, you can run any game. So second thing, right? I just had you just have to prepare a question and run the function. If I write a Python code for tic-tac-toe game, right? I'm asking it to run for only 1 time so that it will not run more. Let me see how it is running tic-tac-toe game. Entering into developer node, then it will enter into tester node, it will generate the node. 1 time after it is done, it will be done. Whatever the developer has given, right, it is giving a complete code there, like a class tic-tac-toe. It is giving all the functions. Okay, so what I have to do at the end of the run is I will have to copy the latest code of the developer and run in a separate cell so that I know whether that is running perfectly or not. Okay, so this is the reflection pattern with the help of which reflection agentic AI pattern with the help of which I am bringing a very optimized code and a robust code. It is able to tell me that it is able to test and tell me everything is fine. Okay, it has already run the code. I think it is giving me in this cell. Suppose if I run the tic-tac-toe game, right? It is asking me, I guess it is asking me here to play the game. Not only that, you can try your own games. If you want to try like a snake game, you want to try something else like um, stone, paper, scissors, right? You have one stone, paper, scissors game. You can try that. Just you have to give a question and call this particular function. That's it. I will share this notebook with you. You can try it out on your own and let me know how it is working. We have only 5 more minutes. I had a small quiz also that I prepared. It's on your own. I mean, you can do the quiz on your own. I will send a link to that. And the questions, there are 25 questions in the quiz and you can let me know how you are doing. I will try to paste that in the chat here. Yeah, so the tic-tac-toe has run and I think it is asking me to try out the game here, right? See here, there are two players here. One is an X player. I can give any number in 1 to 9, like 1, 2, 3, 4, 5, 6. The cell, right? I can give 1 and enter. It is showing me that X has placed here. Now player O, I keep in, say for example, 3, enter. And now I keep in 5, enter. I keep in 6, enter, and so on. So you can keep playing the game. Player X wins. Okay. So this is how I have this. So I will share the notebook here as well in the Teams, right? In the chat, I will share the notebook as well. Or I will share to, along with the slides, I can share to Madam and then they will share across this one. Now we have a question answer session. I'm open to any questions that you have on the agentic AI patterns. Any questions?
Participants, do you have any question? If there is any questions, please raise your hands so that we will get back to you.
Dear participants, if you have any queries, kindly ask. Yeah, Aparna Panda, Madam has raised her hand.
Okay.
Aparna ma'am, please.
Yes, ma'am.
Yeah, good evening. First
Yes,
of all,
ma'am.
it's a really session that we attended. As it's not a query, rather, it's like you have mentioned that the three tools that we can use. Let it be reflection, planning, and that one more.
Yeah, reflection, planning, tool use pattern, and agentic multi-agent collaboration pattern.
Yeah, hybrid can be done accordingly that you have mentioned, right?
Yes, ma'am. Yes, ma'am.
That actually I had it in my mind.
Ma'am, sorry, I was not able to hear your question because it went, there was a problem with the network.
Aparna ma'am, kindly repeat your question, ma'am. Okay.
There
My query was, yeah, my query was that you mentioned that all these it can be used.
Yes,
In
ma'am. Yes,
hybrid
ma'am.
mode, it can be used. Right. So when we have the say, answer or like that, how that agent and that collaboration will be done? That was actually my query.
So when we have a multi-agent collaboration, you're asking how the collaboration will be done, correct?
Yes, yes.
So what happens, ma'am? The multi-agent collaboration is a very complex and dynamic system. Usually what will happen will be there will be an orchestrator agent. He is like a master agent who will take care of the entire coordination. What they will do is, suppose for example, in the AI chatbot or help desk, right? Suppose the user is sending a query and we need to respond back to the user on their own. There are so many agents. What first agent will do is like it will extract the information from the email. That is an extraction agent. And he will try to analyze what is the intent of the agent for what he has raised a query. Then there is another agent who is called as a API agent who will go depending on what is the intent, right? He may have to go into some database, fetch some information, and then come back with that and so on. And so we have here two agents, right? One is an orchestrator agent, supervisor, We have an extraction agent. We have an API agent who is going and picking information and coming back. And we have a response agent who is actually based on these two, right? It is preparing a response back to the user. So what the orchestrator will do, he will take the outputs of each of these agents and he will consolidate depending on the task. And he will send a response back to the user. So there is a complex set of mechanisms and a message passing mechanism that happens asynchronously and synchronously as well, depending on the application, madam.
Okay, okay. We have to implement it then only probably, yeah. But yes, understood the way you said it. Definitely it is going to be complex one, yeah.
Thank you. Thank you so much. And anyone else having any other questions?
Hello, good evening,
One
ma'am.
more.
Yeah, Nair.
One more.
Hello.
Yes,
Madam, please.
Nair.
yes, ma'am. Yes, ma'am. Good evening, ma'am. It was a wonderful session. Got to know many new concepts. I just wanted to ask, ma'am, federated learning and agentic AI, can it be incorporated together?
Yes, of course. That's what I told you, no? So in reinforcement, multi-agent reinforcement learning and federating, you're asking about reinforcement learning or federated learning?
Reinforcement.
Agentic AI plus federated learning, correct?
Yes, ma'am.
Yeah, there are different kinds of learning patterns. Yeah, reinforcement pattern, federated pattern, imitation pattern, and there's a combination of all of this. Yes, we can incorporate agentic with federated as well, ma'am. But to start with, right, I'll tell you in industry, we are actually using reflection agent and tool use agent a lot in any of the workflows, right? And even the planning agent. Multi-agent is like whenever there are complex workflows we are using. So federated learning will come into picture when you want to bring complex learning patterns into picture, ma'am. That is not quite frequently used, but it is possible in terms of the research component analysis.
Yes, ma'am. Yes. Thank you so much.
Yeah, thank you, ma'am.
Any of the other participants have any queries? Kindly raise your hand.
Okay. So if there are any other queries, ma'am, it was really a mind-blowing session. Ma'am has highlighted how generative AI has transformed the traditional AI agents by overcoming the limitations like static models, rule-based logic, and poor adaptability. And she also explained how Gen AI is working like based on the knowledge synthesis, pattern discovery, collaborative learning, and the various patterns like reflection pattern, tool use, multi-agent. And it was really amazing. And she also explained about what are the major disadvantages and advantages, that is decentralized decision making, which removes dependency on a central controller. And a practical case study was also very much helpful, which was using the reflection and tool use pattern via LangChain and OpenAI. So it was really an amazing session, ma'am, with real-time practical skills. And so your insights on multi-agent design pattern was wonderful, and thank you so much for your session. Thank you, ma'am.
Thank you so much. You have done a great consolidation of whatever is told. Thank you so much, ma'am. That knows like how well you are listening. Thank you so much.
Thanks,
Yes, ma'am.
ma'am.
We had a very good, wonderful session on this agentic AI. So I hope that the people may be using it in their research for how it works with the multi-agenting, which is going to be an upcoming research topic. Thank you very much, Adilakshmi, ma'am.
Thanks, ma'am.
Thank you, ma'am. Thank you so much
for your indulgence. Thank you, ma'am.
Thank you, ma'am. Thank you.
Participants, please hold on. So we will be having the next session. The speaker of the next session, Mr. Jay Ganesh, also joined. Please hold on in the meeting.
We have one announcement.
Yes.
Participants, thank you for joining this session number 2 on your day 2 session. The feedback form will be shared in the meeting link that is in the chat box, as well as the same thing will be shared in your WhatsApp group also. And you don't remind us every time that where is the link, etc. In both the places, the link will be given. Your feedback and the attendance has been joined together as a single form today. So you can take the input from this chat meeting chat as well as from the WhatsApp group. But only constraint is that this link will be taking its response only till 10 p.m. today. So kindly make sure those who are attending the session, kindly make sure that you are going to give your response before 10 p.m. today, because we will be ending up our session by 9 o'clock, and we have extended it till 1 hour. So if you have any other internet issue or whatever the reason, you can give your response by another 1 hour. So we won't be sharing it during the session. It is disturbing actually. So let us continue this with the second session also. And you can get your link in both the places, Teams chat as well as in our WhatsApp group. I hope you will be getting the contents. I'll be messaging the same in our chat box also. Okay, people? Okay. Agila ma'am, let us go to the second session.
Yes, ma'am.
Kindly give me some seconds.